Hello and welcome. This is episode 3 of Max MSP. I'm Bjørn Jacobsen and this is my Cujo Sound channel. I hope you enjoyed so far, and if you haven't watched the first 2 videos, please go ahead and do so. In this series, we're going to be going over Max MSP, why it's important to understanding signal paths and flow and coding. So please check it out. It's really efficient if you want to do sound design. It's not a compulsory tool that you need to know, but it's really helpful and it's really helped me a lot. So let's continue in this series. Previously, we created this patch here, which was able to control the various values coming in from my Nano controller here. We can use the fader, we can use the buttons on channel 4 here, and we can use the knob for channel 4. And it's really cool, but what can it do? Now, let's try something new here and double click. And you can see here under audio, there are a number of things here. Let's see if we can find a fader. Isn't there a fader? There's a gain right here. It's called gain. Like if we just type fader, there is nothing. But if we type gain, it's the same thing. So if you pick it from here, gain, or click N and type in gain, it's the same thing. As you may notice, it says gain tilde, which means that it's a fader which controls audio signals. But audio objects like this can also be used to control other values. But to begin with, it should control audio, but we want to control the actual value of the fader with our fader. So as you can see up here, there are 2 inputs and they're really small. We could try and make the fader bigger. So there is here. By the way, it automatically becomes scrollable. So now it scrolls left to right, but if you have it taller than this wide, then the fader goes up and down. Just for the sake of experimentation, let's go from left to right. Now, so this left input here actually does 2 things. It takes 2 things in. It can take a signal, which is the signal that you want to scale, and as you can see, it also says that integer sets the value. So if we take our fader 4 here, let's just put it in. So you can see that this is the number box that basically represents this value. So if we turn my fader up and down, I'm now controlling the volume of this. And notice how it is set to, when it's 127, the bar doesn't go further than this on this fader. And that's the reason, because in here, you can always go left, and there's this little eye here, and you open up this box, which is the settings, the inspector for the specific object that you have. And let's say here we have values. In this window, you can either see all, you can group all these things, but under value, you can see here that it has a number of steps. It has 158, which means that it has about 31 more values than steps than we are sending from 127. So if we set this to 127, the fader would then go all the way to the top. The reason why this is happening is simply because that by using this 158, that means that if you're gaining volume, then this, by having the fader all the way to the top, it doesn't gain. You only use it to decrease gain. So it doesn't go above 0 here. Now let's try something else here. If we have press N and type in meter, we can have a meter like this. And this also takes an input, which is a sound input. Now let's try something here. If we press N and type ADC tilde, this is the ADC, this is the same as the analog to digital converter. This is where sound comes in. Now, as you can see here, start, stop, turn audio on and off. This requires a toggle. So basically we can, actually this ADC one here is the same one as if we go into double clicking and say here, as you can see here, it's called EC ADC or EC DAC, which is, this is the output. So it's just easier to use if you use this. I just think it looks stupid. I prefer this one here. But if you have a toggle and put it in, then audio will be on. Now if we go up here into our DSP status, you can see here that sound is off. Let's drag it over here. The audio is off, but if we have a toggle, press T and go into here, hold Control and click it, then you can see this toggle basically represents if sound is on or off, and you can also see it over here in the DSP status that sound is now on and off. So, but how do we do the toggle? We have this here, our Nano control, which we can send to over here. So now the solo button of channel 4 strip now turns on and off if we want sound on and off, if we want to run any kind of processing. And that's how you do it. You can also see this other icon here. It changes color, which means the sound is on, sound is off, sound is on, sound is off. And that's a really easy way of signal path controlling that a basic button input on your Nano Control 2 or any other MIDI keyboard controls the input of a toggle, or the value between 0 and 1, or the value in this case between 0 and 127. But the analog to digital converter inputs or objects, they take a toggled value, which means that now this button is toggling that value. So sound becomes on and off. So let's try something out here. Automatically, it has two outputs. This is channel 1 and channel 2. And over here in our output device, we can set, or input device, we can set which input we want to use. We want to use analog 1 and 2. So let's say if I have this microphone that I'm talking into right now, it's plugged into channel 1. So let's try and drag it down here to the meter. And then let's use our button here to turn on sound. Yes, now that as you can see, the meter is instantly checking that sound is coming in, and that means that our input is working. We can also do it like this, so that it's not as, if it's taller than it is wide. The same thing with the gain. It now registers what I am saying into the microphone, and it comes out like this. So what if we add the gain one instead, and say this goes into the value, and we can easily see here that this here is the scaled output and comes into this one here. So now it's set to 0, and we want our fader here to control that. Let's get rid of all of this so that it doesn't look so messy. Here we go, like this. So now, as you can see, we can turn the sound on and off by hitting the button here on the Nano control, and we can use the fader to control the input coming in from over here on our Nano control fader patch, which we made before, which now controls this fader. And that value is directly transferred into this one, into the meter, into the fader that we have right here. So what if we turn on the sound like this? And now you can see the meter isn't doing anything in regards to what I am saying. But if I start talking and I turn up the volume, something should come in. And it does. Something comes into the meter. But if I turn the volume down, nothing's going to happen. Nothing is coming out of it. So that's a really easy way to use the value of whatever you have to control either a meter or a fader or any kind of volume control like this. And if I turn the sound off, of course, instantly something's not going to go to the meter, so here we go, and now it's off. And it just simply stores the last value that it was at. It's really useful. Now, the difference between this fader here going into this one is actually that this simply just scales the signal. So what we could do is that we could add, instead, if we want to do something else instead, we can say multiply, and this is just a star, multiply tilde, because we want to multiply the actual sound signal. This here is multiply. This here is the inlet, and this here is the float value that comes in. This is the signal. So if we do like this and say that the goes in here and here, if we say multiply by 1, it should go in, and now it registers what I'm saying. So if we take our Nano controller here and then say we go. And then turn down the volume. Now it's off, now it's on. We can even have it like this. But we could also say that we want to scale this value here. Scale is an object that takes 4 values. It takes the value that you want to go from and to, and the values that you want that to be scaled into from and to. So we have a value coming in from 120, from 0 to 127. We want that to be scaled between 0 and 1, like this. And as you can see, actually we want it to be scaled between 0 and 1 float. Float means that it comes out with floating points, of course. So if we press F as a floating point here, then you can see that when we touch our, and when we use our fader here, it'll change the value between 0 and 1, but also in floating points, because this one over here wants to multiply by floating points. So if we put it over here like this, then it should work like that. And if we turn down the volume just a little bit, it fades out slowly, slowly, slowly. As you can see, the signal is loud now, and now it's non-existing. So we could also, instead of that, as you use this as a mute button, and then have a toggle, which is from up here. So this is now the S button. So now it multiplies by 1. It multiplies the signal by 1, meaning that it's coming out of the 1-to-1 strength of amplitude. So if I turn it off, nothing's going to happen. Nothing's going to come out of it. We can even, if we say we want a float, a number tilde like this. And a number tilde just takes an audio input. Now this is this basically shows the waveform value between -1 and +1. And whenever you go above, it goes above 1, of course, which it shouldn't do. So in order to, whenever something comes in like this into the meter, and we have this, we're right now multiplying by 1, and it comes in, we can also use this Nano controller over here, which is our fader, which is now being controlled over here. We're using this scale object here. But we could also just have used a divide by 127, because mathematically that is the same. Here, and we can send it to an integer like this, which means that now the value is 0, and as long as we reach 127, it becomes 1, like this. 1, 1, 1, 1, 1. And this one over here on the left is of course a float value. But how could we do that in another way? We could say here divide by 127 float. The integer still works like that, but if we press F and add a float object here like this, we will get exactly the same value as over here. So this does the same. Divided by 127 float does the same as this scale up here, which scale. The scale object is just really easy to use if you want to go from very obscure values to very obscure values, and you want to have that into a something something. Also, if you want to use variable parameters, variable numbers here, you can do that with the scale one. You can also do that down here, but it becomes more complex. Now, if we add the gain again here, you will see that it has 2 inlets and outlets, as we talked about before. And if we drag and drop our integer value here, it goes from 0 to 127, and it comes like this. But it also has the slider value out here. So we can add an integer here and go here. And the value is coming out like this. But that also means that we can take away this and log it, and we can then just manually click and drag and drop here, and then alter the value with the mouse, and then the value comes out here. The interesting thing about that is that this clearly shows that whatever values we are using, the numbers just continue. They continue through every object. They're not necessarily changed all the time. So it's just a matter of signal paths, and this fader here is just a representation of what is the current volume, basically. Now remember this multiplication up here where we previously used the fader to do that? Well, this number that's coming out of the fader down here could use a float value. So if we say this float value here between 0 and 1, if that value was sent to over here, we could turn on the sound by hitting the solo button like that, and now we're talking. You can see on the meter that something is coming in, and if I turn down the volume, something is being faded out, so to speak. And that is this value that comes right there, that comes in from this, which means that we are now using this fader, but it's go through all this logic to control this number. It could also be this number, it could also be this number, it could also be this number that does it. It doesn't matter. The number is the same, and mathematically that makes sure that whatever comes in comes out in the other end. And that's really important to understand, that numbers are never changed. They only go through the logic that you give it, and then they change into whatever you want it to change to. They don't change by themselves. That's it for episode 3. That's a little bit about faders, a little bit about numbers, basic math in Max MSP. I hope you enjoyed it. Sign up on Patreon, hit the subscribe button, like it, whatever. Go to Twitter, YouTube, Facebook, Instagram. Follow there. For fuck's sake. Some Indian dude wants to sell me Microsoft products. Yeah, that was my ringtone. That is Igor, a track by Igor called Beyond. I love it. It's great. It's my ringtone. People always look at me like I'm messed up when the phone rings while I'm on the train or the bus. But who cares, right? Hope you enjoyed the video. See you in episode 4. Bye.